So I'd like first start to welcome all of you to our topic today of the MAA webcast series, which will be Edition-Based Redefinition, or EBR for short. And the focus a little different this time around. It's on application upgrade as opposed to our tried and true topics of database upgrade and database disaster recovery and high availability. This time we're focused on a database feature that goes ahead and enables application upgrades. And with me today, I have a whole bunch of our EBR engineering team members. So feel free to go ahead and type in a Q&A, and throughout my presentation, hit them with whatever you want, and they will go ahead and respond to questions. I will also go ahead and we can pick up at the very end of the series too. I can go ahead and respond to some of them in the presentation at the end. So I'm going to go ahead and get started. I'm Glenn Hawkins. I'm our Senior Director of Product Management. I'm on our maximum availability architecture team, as well as our edition-based redefinition, data guard, flashback, online redefinition. So a bunch of different HA and DR technologies underneath the Oracle database umbrella. And I'd like to go ahead and kind of kick it off just by kind of talking about the goals. And then we'll just jump into where EBR kind of fits in with our overall portfolio of capabilities. So the goals of EBR, what we're trying to do is to allow arbitrary changes to a set of artifacts to application database record, right? The idea is to go ahead and provide zero downtime for your application when you're going ahead and upgrading it. Means to have a bunch of different artifacts under the covers that run inside the database, whether those be tables, stored procedures. And ideally, you'd want to be able to go ahead and to achieve that zero downtime, you need to be able to use both the pre-upgrade version of the application simultaneously with the post-upgrade. It's the only way to do it. So you have to have a hot rollover to be able to go ahead and achieve that. And our goal when we created this is to maintain uninterrupted availability of the application during that process and ensure there's no negative impact to performance, of course, as you go through it. So this is the focus of the solution. You'll see that reiterated over and over again as I go through the difference. You'll see that reflected in the different features that we've gone ahead and created for it as part of EBR. And if we look at the way application upgrades, and here at Oracle, we focus on the database quite a bit. You know, as far as our database, our maintenance, our disaster recovery. But high availability, of course, is the full stack. Everything across the board, you need to make sure your application's up and running. That's what keeps your business running. And there's a lot of different aspects to that we've gone ahead and considered in regards to RTO and RPO. RTO is a measurement of downtime, and RPO, recovery point objective, is a measure of data loss, potential data loss. So we focus on quite a bit of that. And planned software changes, surviving hardware failures, data center outages, any type of infrastructure down, you know, and then logical errors as well that might happen, human errors that might occur. And of course, changing the database application, database objects as part of those planned maintenance. And let's keep in mind that planned maintenance happens a lot more often than failures, right? This is a more common occurrence. And if you care about your business continuity, it needs to be one of the main focuses. Now, the key to going ahead and changing the application's database objects without impacting the application is you need to change the object's meaning, the patching, right? Whether it be a stored procedure or your table, or you're adding a new table, or you're adding some new columns. However, you're going ahead and modifying that to accommodate the new version of your application. So that's kind of the key of tying that in with all the other capabilities that we have here at Oracle. In maximum availability architecture, for those unfamiliar with it, we have different tiers that tie into different RTO and RPO values. Depending upon what your SLAs are, that you can go ahead and handle downtime or potential data loss. We have the bronze, silver, gold, and platinum. A lot of different technologies go ahead and fit into this. They've all come from experts that we've gone ahead and worked with over the year. We've worked with customers over the years. A dedicated team came out of that to focus on MAA. We created the reference architectures. And these mirror in all the different features that we've gone ahead and provide, right? From continuous availability, which you can see EBR is part of, right? To go ahead and maintain at the top, along with app continuity and online redefinition. And then we have data protection to go to protect your data so you get zero data loss associated with that, anything occurs. Active replication and scale out. And there's a lot of integration between these different categories. And a lot of our features even go ahead and span multiple categories in there. We have all the different deployment choices. EBR would be applicable to all the different deployment choices, whether we're talking about generic systems, DBCS, XCS, Exadata, or all the way up to autonomous. And then if you're migrating in the cloud, we also have our zero downtime migration, which has features like Golden Gate, data and Data Guard integrated directly into them to go ahead and facilitate migration to either the cloud or Exadata as well. So back to application upgrades. How can we go ahead and support online application and keep that uninterrupted availability for the application along the way, right? So you have users, your end user sessions, they're connected up to the application. They're running along, they're going ahead and utilizing it. That means that sessions, there's active sessions against there. You can't just cut those off. No matter how fast you bring up the other application, if you just cut off those old sessions, those users are going to be impacted at the end of the day. So that needs to be avoided if you want to go ahead and provide that uninterrupted availability. It's very, very important that we go ahead and focus on that. And thus, that pre-upgrade and post-upgrade is critical. Your current application, meaning your pre-upgrade, that's what people are running against right now, and the new version of your application that you're bringing up and running. And we're going to go ahead and focus on. So we refer to that as hot rollover, as you can go ahead and migrate the user sessions as session ends. When that session tries to reconnect, you want it to be able to connect up to the new application. This is the goal, to go ahead and provide that uninterrupted availability. So the challenge of that is in order to keep a pre-upgrade, so your current version of your application up and running with your post-upgrade, your new version of your application, the changes that happen can't impact the older version of the application. It has to stay up and running, has to keep running. You really want it to run with the same database infrastructure. The other trick is that you need to ensure that transactions that are happening, whether happening on the current version of the application or on the new version, they need to be reflected in one another. Otherwise, you're going to have a data integrity issue. So you need the transactions to be propagated between the two. So it's automatically reflected in there. And then we need to be able to go ahead and ensure those transactions as they're going and rolling across. That's a very seamless integration, meaning we don't want to break an existing session of the application that's already connected as we go through this. And this is all very challenging to go ahead and accommodate to ensure you go ahead and really achieve uninterrupted, basically these applications up and running and do this hot rollover. So within EBR, you're going to hear 3 different types of new terminology that you may not have heard before if you're unfamiliar with it. The first is edition, and you can think of this as it's basically providing this is where your code changes can go ahead and be reflected from one edition to another. An application will be connected either to maybe the current edition or a newly upgraded edition that's going ahead and rolling out. It's where we can go ahead and make all the changes to our store procedures, and we can go ahead and reflect new changes in our columns and tables. Within there, we have editioning views. These are basically representing your tables, and they're exposing a different projection of those tables into each one of the editions. So as the user connector, they get the editioning view, as opposed to going to the physical tables. So we'll talk about that a little bit more. We'll talk about why that's the case. And I think it'll be obvious with some of the examples that we have. And then we have to go ahead and propagate those changes. We need to make sure they're reflected in both sides. So that's the cross-edition triggers. Their entire job is to propagate data between the old edition and the new edition and vice versa. So those transactions for data integrity need to happen in both directions associated with that. And I'll go into more detail on each one of these, and we'll have some examples tied to these as we go through. So let's start with how this looks. So if we're going to go ahead and achieve a hot rollover, we have our existing application. So we have our load balancer sitting in front of it. This is a very, very simple application. You may have multiple tiers represented in that app tier, but let's say they're all condensed into this run app that we have in there. So that's our mid tier associated with it. It's connected to a bunch of database objects that you see reflected there. And then within our database, so we have a single database in this case, with our run edition in there. So that's our current version of the application. Current load against there, tens of thousands of users may be connected to this critical application. And we certainly have customers today that are using it with this many customers, many more than that, in fact, hundreds of thousands. So as new application clients come in and connect, they'll connect to the load balancer, and they'll be directed to the run application, right, which is connected and going ahead and facilitating that load and handling their transactions and their sessions. So normal use, pre-upgrade, new clients coming in, new clients are connected. In this case, the load balancer knows where to put them. It may have a cluster of application servers that are going ahead and running against it. It's going ahead and directing them against. So now we want to go ahead and our app development team has gone ahead and just created the new version of the application. So it has a bunch of different schema changes associated with it. It has new store procedures, and we're going to go ahead and create a new edition in the database. And we'll talk a little bit more how this works. Essentially, we're using an inheritance. Inheritance basically state to go ahead and create a new version of that edition associated with it, right? And we'll talk about how that works a little bit later. So once we have our database objects in there, we have the ability to go ahead and bring up the app server that's tied with that. So the app server is connected up, so it's going to go ahead and connect up to the patch edition. Now we'll decide, depending on the database user that's connecting, which edition it's connecting to, right? And now we have our load balancer up there and running. And as a new client comes in, we can decide. So we can have some of the clients could still be redirected back to the current application, or they could be on the patch edition. So you have now a choice to go ahead and maybe take a subset of users and have them run on the patch edition to go ahead and kick the tires of it. So you can slowly phase out. So that's another advantage that you have by going ahead and do this hot rollover capability. So it comes in, it connects up. So this is maybe our first application client, or maybe we have 100 of these that are going in and connecting up to patch edition. And both of these are in sync with each other. We still have the data integrity associated with it for all the data that they have in common with each other. New patch version may have some new tables, so new editioning views, as you'll see as we go ahead and talk about it a little bit later, reflected in there. In store procedures, and we could also be dropping some or making them unavailable in the patch edition as well. So we can make all the different changes in there. We have more clients go in and connect up. We're gaining confidence. We go, okay, things are working pretty well. At the same time, the sessions on the older version are running out. So now we want to go ahead and we want our load balancer to start. As they connect back up again, we'll go ahead and have them also connect up to the patch version. So as we go in and run through it, we'll eventually get everybody connected up onto the run up. We have nobody running on the older version. Everything's really running well. Our development team's really happy with the way things are going. So we'll go ahead and start referring to the former current version of the app as the former run app. So nobody's connected to it. It's still up and running. At any point in time right now, I could always go ahead and have the load balancer start feeding sessions back into the former run app, right? I could go ahead and have clients that are connecting up. I could go ahead and start sessions on that app if I desire to at this point. But I'm not going to go ahead and do that because everything's running great. So now I want my newly upgraded version to be the only version. So I'll shut down the app servers. I can go ahead and take them down. And at the same time, I can go ahead and drop. Well, not drop, but go ahead and we no longer need to go ahead and refer to our older edition of the application at this point. And we're up and running. So now we've gone ahead and successfully done our application upgrade until the next time we want to go ahead and run it. And we have customers that do this, that use EBR on a very, very common basis. Some of them, it's every 6 months. Some of them, it's every 2 weeks that they're going ahead and they're running new patch versions. Some of them have very small patches that they're going ahead and running out. And they have this integrated into their entire system as far as their application lifecycle to go ahead and roll it out. It's a very, very critical piece. It's also, by the way, what we use for a lot of our applications at Oracle. So you hear EBS talk about zero downtime upgrades. That's EBR under the covers to go ahead and achieve that. Anytime you hear a zero downtime upgrade, it's EBR that we're going ahead and is facilitating and enabling that functionality. All right, let's go ahead and start looking at the data. So let's go ahead and jump into this, and we have a case study now. So if we look at the original current edition, we'll call the run edition, that's going ahead and running it. We have one of our editioning views has a first name, last name, phone. This has become kind of an issue maybe from reporting purposes, and we really want to split that phone number into a country and a phone number separate. So we want a country code, we want to separate it out. So how can we go ahead and facilitate this very kind of simple example? So the new version we can see has a country column and has a number column where we've gone ahead and made that split, and the phone number column is no longer reflected in there. So we've gone ahead and tied that in. So keep that in mind. We're going to come back to that example here in a moment. And I'm just going to go ahead and talk about some of the moving pieces here in a little more detail, and then we'll return to that, and I'll show you how this actually works within EBR. But the few things to keep in mind is a lot of times when you've gone ahead and you've done an upgrade to an application, there's 1,000 mutually dependent code objects that are running in there, right? a lot of stored procedures, lots of tables that you have running in there. And in general, you're going ahead and making changes to a very small amount of these to go ahead and handle your upgrade. So maybe you've gone ahead and added a new table, which would have a new editioning view, as you'll see here in a moment, associated with it. But a lot of times, they'll say you only need to make change to 10 out of 1,000 of these objects, right? So here's what you're basically looking at the end of the day. And ideally, you don't want to take a bunch of downtime to go ahead and facilitate that. And with EBR, you don't need to, right? That is what is going ahead and delivering you, allowing you to have version 2 of these 10 change objects while leaving all of version 1 alone. And for those that are familiar with application development, it's using inheritance at the end of the day. You can think of it very much like a Java class where you're going ahead and working with inheritance with a parent-child relationship associated with this. Hierarchical is the way EBR works at the end of the day. So we can go ahead, if you try to do this with just your tables, your physical tables, you can't change those 10 objects in place because you don't have the concept of being able to keep the old and the new simultaneously together. An old and new occurrence is the same object, right? Like a table, they can't coexist. So you would break the older version of the application, and thus there's no way to get zero downtime at that point, right? You have to go ahead and and deal with that, bring down your older version of the application, drain out all the sessions to go ahead and achieve that. So what EBR with the addition, we've gone ahead and introduced another namespace, essentially, another naming mechanism associated with this to go ahead and provide it, because the older one, pre-EBR, was not rich enough to go ahead and facilitate this. So with EBR introducing this non-schema object type, this addition, we have the capability to do this. So a database must have at least one edition, and you guys may not even realize it, but essentially what you're working with is you always have editions built into the Oracle database, and it's available for everybody that's using standard edition or higher. This capability is available to you. A new edition, each edition can have one child associated with it, and it works like a hierarchy. So you can have many children going in and kind of building on there in a chain of them, and you essentially have leaf nodes at the end of that. You have your first one, and you have your final one associated with it, right? That we kind of think of them as leaf nodes. And it's important to distinguish, as that's how you'd be able to drop additions in each leaf. So you can think of it as a chain of additions, with each one having at least, or having a single child. A database session can go ahead and choose which edition to connect to based on the user, but your database can also have a default edition associated with it, which means all users will connect up to that default if it's not specified. So when you create a new edition, every edition object in the parent edition is going to be copied to the new edition by default, right? That's the way it's going to go ahead and work. So let's go ahead and look at the way that works. So we have our additional objects. So some of these we'll talk about a little bit more, but let's assume there's some tables now represented by editioning views, because we don't have physical tables, and then we'll talk about why here in a moment. We have some store procedures. So these different objects can be different type of additioned objects. And here's our new edition. So we create a new edition and inherits. By default, it's inheriting all the previous objects. Everything's exactly the same. So our old edition is going to exactly like the new one. And then what we can do is we can actualize some of those objects, which means we're ready to go ahead and change them. So we'll take object 1, object 2, and we're going to change those. Now the inheritance is no longer broken. It's broken at this point, and the actual version is now represented in our post-upgrade edition at this point. Object 3, object 4, all the rest of the objects are just going ahead and using inheritance at this point, and they're still represented in the parent edition. At this point, we can go in and drop. So maybe we drop object 1. It's no longer represented. So anybody that connects up to our new edition can't access that, imagining its editioning view. It's no longer available to them, or a stored procedure. So we can decide how that's going to go ahead and work. And this is the way basically editions work at the end of the day. So if you ever upgrade consists of synonyms, views, or PL SQL, you have all the tools you need at this point. And you can go run scripts associated with it. You can change your default edition and let new sessions go in and connect to that by default. And basically, patches not discarded. You're not going to get any patches state discarded errors ever again at this point, right? If you're going to utilize this. However, not all objects in the Oracle database are editionable, right? So we talked about synonyms, views, PL SQL, but some objects, in particular tables, are non-editionable, right? Because if we go ahead and start changing the physical table, there's only one of those available in there. And we will go ahead and we'll essentially break the older version of the application that's going ahead and connecting to it. So we need to go ahead and keep that the same, right? So you have to start having a new way of thinking about this. As you go ahead, like you have a new column, you have a column that exists today. Instead of going ahead and dropping a column or changing a column, you want to add a replacement column. And this is the way EBR works fundamentally at the physical table level, right? That's what's going to happen under the covers, right? Now, editioning views is how we're going to take those tables and reflect them in the different editions, right? As I mentioned, we're not going to drop columns. We're not going to change columns in the original physical table. Instead, we're going to add new ones, and then we're going to have our editioning views go ahead and project those, and they can be renamed. And this is what your application is connecting up to. Application code should only connect up to editioning views. No more physical tables associated with it. And that's how you go ahead and provide that layer of abstraction, right? So editioning views are going to go ahead and allow us to have a logical projection in there. And we have it for our current application. We have it in our new application associated with it. And this goes ahead and provides the safety and the privacy necessary to go ahead and keep that up and running and facilitate our hot rollover capability that we have there. You can go ahead and have triggers associated with this, right? The SQL optimizer at the end of the day, it can request an index on the physical table by specifying the logical column name. So it basically, you have all the same capabilities as you had before, and the execution plan is exactly the same. So there are no performance consequences associated with having an editioning view and having your application go against it instead of the physical table. You only get benefits at the end of the day associated with it, because you get the capability, you start rolling toward what we're trying to do with the hot rollover. All right, so an object, a couple things to go ahead and think about. An object type is non-additional. It can never be addition. So the tables are non-addition. We still have the physical tables kind of represented there. They're not represented inside each one of the additions. And you cannot have a non-additionable object refer to an addition object. Now, there's a few little caveats associated with there. I'll go through with materialized views and so forth, how we go ahead and deal with that. Materialized view is another one that's a non-addition object. So how can we go ahead and facilitate that? So we have some special capabilities for certain objects, but from a kind of a default way of thinking, you don't have a non-additioned object referred to an additioned object associated with there. So all your store procedure and everything are going through your editioning views and so forth to go ahead and provide all those capabilities. So I mentioned materialized views, indexes on virtual columns. Some of them have special capabilities. And we've added a new evaluate clause to go ahead and decide which materialized view can go ahead and go against which edition. So you can specify materialized view is a non-addition object, but it has this evaluate clause to go ahead and allow it to decide which edition it's going to go against associated with it. And there's lots of tricks. There's some tricks with synonyms as well that you can go ahead and utilize to go ahead and tweak this on edition by edition basis to go and facilitate materialized views. It's one of the biggest questions we get, and we have FAQ, by the way, up on the EBR site that specifically talks about materialized views and actualized objects. So a lot of this terminology that I'm talking about that you can go ahead and look at for some of the commonly asked questions associated with that. And I'll show you all the resources at the end of the presentation as well. Now, the other big thing is the cross-edition trigger. So the cross-edition trigger, as I mentioned, its job is to go ahead and propagate the data and keep the current version of the application in sync with the upgraded version, right? To keep our data integrity the same. As new transactions come in, those are reflected. At least the columns and the objects that they have in common, they're reflected on both sides, right? And thus, there has to be cross-edition triggers that go in, and we have basically forward and we have reverse ones, which I'll talk about here in a moment. And these cross-edition triggers directly access the actual table. They're accessing the physical table at the end of the day, but they're part of the edition associated with them. They have special firing rules that are specially tied with the cross-edition triggers. So we have forward cross-edition triggers, which are going ahead and propagating things in the direction of from your current version of your application. So you have somebody's gone ahead and created new rows in the current version application. Its job is to go ahead and facilitate that and push it to the new post version, and vice versa, right? is going to go ahead. If the transactions coming in on the newly upgraded version, we want to push those back to the current version. So any sessions that are still connected to that, it's still being reflected there accordingly. All right, I'm going to jump into another example in a moment, but I'm sure one of the questions you're going is, well, okay, what's involved with doing this? Do I need to make a bunch of changes to my application to start considering EBR? How can I think about adopting this? And how do most customers go ahead and start adopting this? So the first step to think about is your table. So we'll start with the tables are kind of the key to it, right? And I mentioned that tables cannot be additioned. So we need an additioning view in front of each one of the tables. Each table can only have one additioning view tied to it. So the easiest way to do this, and I realize there's a lot of caveats depending upon your application and what's accessing it. But what a lot of customers do is they rename their physical tables, right? So obviously you're going to have that. This part of this maintenance, your first time you're adopting EBR, there's some downtime associated with that as you go ahead and make the fundamental infrastructure changes if it's an existing application. If it's a new application, you can plan this from the very beginning. But so you rename your tables. The easiest way, people put an underscore in front of their table names. And then they name their additioning view the same as their original physical table. And that means all the SQL in their application will go ahead and connect up to the additioning view without having to make any changes to the actual application. So people find this to usually be the easiest way to do it. And I would say for 99% of our customers that are using EBR, this is how they go about it, to go ahead and do it. And then you revoke privileges from the tables. You don't want people connecting to them anymore. You don't want them to accidentally connect to them anymore. That will break your application. So to make sure everybody's going ahead and behaving themselves within the application, you revoke the privileges to the tables to make sure they're going ahead and going against the additioning views. You can move your VPD policies to the additioning views as well. Move the triggers to the additioning policy to the additioning views associated with that as well. And as I mentioned, even the cross-addition triggers that we're going to talk about here in a moment are tied into the edition itself associated with that. So you have all indexes on the original tables remain valid associated with that. And all your constraints, your foreign key constraints, they are basically on the original employees that remain in force that are represented in your editioning view are still remain in force on the physical table, right? Which is now, in this little example we have, is employees underscore associated with it. So that employees underscore is our physical table. Employees is now our additioning view. Foreign key constraints associated with that are going to go ahead and be enforced on both. And it's very important, especially if you're creating a new column as you go ahead, you need to populate it, for example, before you go ahead and turn on a not null constraint or something like that associated with it. So there's an ordering to the way you go ahead and roll out some of these changes. So the writing work is done, and some people will go ahead and make this their only change. The very only change that they'll make in the very first time they adopt EBR is to put that additioning view in front of their physical tables. That's it. They don't make any changes yet. We're going to go ahead and we're going to start there and then bring our application up and running. And that will go ahead and we're using additioning at that point, and then we can start going ahead and utilizing it for its full intended purpose to give us that hot rollover, that zero downtime upgrade. But this is the first price, basically the price you pay to adopt it. It's this one-time cost of getting the additioning views in front of it. All right, so let's go back to our case study. So here we go. We got our first name, we got our last name, we got our phone number. In the original current version of the application, we have 100,000 people connected up to that application. They're going to be using it in our employee table in this case, and we're going to go ahead and roll out our upgraded version, which is splitting that country code and that number. So we have this up and running. Our run edition is connecting up to it, maintaining the employees, connecting up to our employees editioning view, and we have our primary key, we have our phone number, and then we have a bunch of other columns. But those are the ones that are important. So this is an employees underscore. This is our original. This is basically the employees underscore. Keep in mind is the physical table. Our editioning view is employees, and it's going ahead and connecting up to it, and it's using that old phone column associated with it. So it's time to go ahead and bring up our patch edition. So we've gone ahead and we've created a new version. We have our procedure maintain amps. It's going to connect up to our new edition, right, associated with that. We've gone ahead in the physical table now. We've gone ahead and added a country and a number column associated with it. And our new patch edition is no longer connecting up to the phone number column. It's going to go ahead and connect up to the country code and the number column associated with that. So now we have them up and running. Both applications can be running. We can move at this point. We can move 10,000 of those users when they reconnect up to the load balancer. They can be those clients can be connected up to our app servers that are connected up to this patch edition. So we have our hot rollover at this point. But what we need is to still propagate. Basically, we need to go ahead and ensure that our data integrity is the same, and that any type of transactions that are coming in the patch edition are reflected in the older edition, the current edition, as well as vice versa associated with that. This is where our cross-edition triggers come in. So we have our first one that's going to go ahead and have our forward cross-edition triggers. And these are transactions that are coming into the current version. So they're going ahead and they're populating. If you have a new row or a changed row, it's changing that phone column, right? But it's not populating the country or the number column. That's what our forward trigger is going to do. So this trigger also is probably the exact same script that we're going ahead and use the first time around. When we introduce the country in the number column, we probably use the same code to populate that country in the number column. So the trigger is going to do the exact same. If you've got that phone number column, its job is to populate the country in the number column in the patch edition. So it's going ahead and represent it in both places. So that's its job, and vice versa. So we're going to go ahead, as new data is coming into the new upgraded version of it, we want to go ahead and populate the older phone column. So it's coming as populate our country in a number column. We're going to go ahead and push it the other way, and we're going to populate it. These cross-edition rules are part of the edition itself. So they may not be necessary in future editions as we go ahead and move forward. Probably not, right? Because there may not be a phone column moving forward. This is the way it works in a nutshell, right? Our to-be run edition, our present run edition, everything's up and running, everything's using, and eventually we'll go ahead and hopefully, if everything goes according to plan and we really like our upgraded version, we're comfortable with it, we can leave it running as long as we want in this manner, and then we can go ahead and cut over eventually, and we can go ahead and drop, right? There we go, the phone number column is now default, nothing's being populated on it. What if something went wrong though? What if we want to go ahead and roll back? How easy is that? Very, very easy. You're probably already realizing that it's the exact opposite of what we just did. So now let's say, wow, we're not very happy with the upgraded version. Let's go ahead and have our load balancer start feeding as clients come in. We're going to connect them back to the current edition again. So that's fine. All the data integrity is still there because our cross edition triggers have been handling that. And we can just do the exact opposite. We'll take the upgraded version down. We'll create a new edition from that, and we'll go ahead and make changes to it accordingly, right? Or we could drop it. We could drop leaf editions and create a new one. So we could do that however we desire to, but we can go ahead and take down the upgraded version for the time being and make whatever changes we want to it. So that, in a nutshell, is how edition-based redefinition works. It's bringing this new terminology in that we're going ahead and kind of consider from a standpoint of the editioning view, the cross-edition trigger. It goes ahead and works with all the other capabilities that we've gone ahead and talked about so far. A few things to think about, since as far as kind of caveats there, is where, as you go ahead and you introduce your editioning views, one of the things you think about usually is what else is connecting up to your application that might be using editioning views. And that's important. We have a lot of customers using Golden Gate, for example, to populate reporting type applications. So Golden Gate requires that it goes ahead and connects up to the physical table. So it's one thing to think about is, okay, well, as part of this change, I'm going to have to go ahead and make sure my Golden Gate scripts, which have to go against physical tables, are going ahead. I'm going to have to make changes to them to go ahead and accommodate that. So unlike everything that we have in our bronze, silver, gold, we have edition-based redefinition as part of our platinum tier MAA, as it requires a few changes to think about. It's similar to the other technologies that we have on there, because platinum MAA is designed for zero RPO, whether you're doing planned maintenance or you have any type of disaster that might occur. But it does routinely have some changes that you need to know. With Golden Gate, conflict resolution becomes an issue if you have an active multi-master environment. Sharding, which we have in there as well, requires that you go ahead and think about the sharding key if you're splitting the application into shards. Once again, the application needs some thought associated with it. And the same with EBR, mostly in the context of the editioning views. We need to get this into the lifecycle. We need to go ahead and put those editioning views in front of the tables And by far the easiest way to do that is the way I described, to go ahead and put that underscore in front of that. But there's some things to think about to go ahead and achieve this. Once you have it, you have your edition, you have your edition view, your cross edition triggers there. Your code changes are now installed in a private version of your edition, which means it doesn't impact the current edition associated with it. Once again, inheritance are tied in with this as we go ahead and kind of tie in with that. So when you create a new edition, it inherits all the database objects that are editionable from its parent. Data changes are made and safety to go ahead and tie with this. New columns are not dropped or not changed. New columns are replaced. We put in replacement columns associated with that the editioning views refer to associated with those. And then the cross edition triggers, once again, are handling all the propagation associated with this. And I routinely see people go ahead and tie with the editioning views, and then maybe the cross edition triggers come in a little bit later. But the cross edition triggers are required for you to have the hot rollover capability. So hopefully you've been typing a lot of questions. If you haven't, you should be, because we have the EBR engineering team on the hook, go ahead and responding to you. Now, for those that are looking for it, I mentioned a few of these things already. I mentioned the last point there, our EBR FAQ, very, very useful for understanding terms like actualizing, how can older editions be dropped, how can materialize views, how that evaluate clause, how we go ahead and handle that. All that's in our FAQ, which is growing all the time. We're going ahead and we're adding new capabilities to that. As a starting point, we have a chapter in 21C or 19C that you can go ahead and look at specifically in the Oracle Database Development Guide, where you can go ahead and you'll be able to be walked through how all this works. You get a lot more information there. Very, very detailed technical paper on adoption, has a lot of our recommendations in there associated with it. On oracle.com EBR, you can find the paper already out there. And you can go ahead and see the short video. We've walked you through some of these. You can share it with your colleagues. It's only about 2 minutes long, the quick EBR overview video, which is probably going to be the first of a series of shorter videos that I'll be rolling out on the subject over the next 3 to 6 months here associated with this. So with that, I will go ahead and stop, and we will go ahead and answer some additional questions associated